I hope everybody's doing well despite the current COVID-19 situation. I'm sure you're all just as restless as I am to get back out of your homes and back to the real world. As much as I love watching Tiger King and Joe Exotic, I'm ready to get back to my real life. Um, just a brief introduction for those that don't know me already. I'm Jeff Fiorini, the Director of Automation for Adams here in Tampa. We are the exclusive provider of Cognex vision systems here in Florida. Therefore, our sales teams and engineers have many years of experience under our belts to help you with any application that you may have in mind. I have no problem saying that we do more machine vision in the state of Florida than anybody else. So I thank you for joining us on this webinar, and hopefully some of you have attended our other sessions this week that we've been doing while we're all working remotely. Keep an eye out. We're trying to do our best to engage our customers at this time. We understand that there's no time like the present to fine tune your skill set or get up to date on some of the technology that is being rolled out, this being no exception to that. So I really appreciate you joining us. I personally spend the majority of my time on machine vision and robotics and have been doing so for just about 5 years with Adams as the need for automation has drastically increased. I'll be walking you through the product rollout today with Ben Voorhees from Cognex. Ben is based out of Sarasota. If you don't know him already, has been with Cognex for just over 4 years. But if you talk to him about the technology, he's by far one of the sharpest reps that they have in the country when it comes to this technology. We're very fortunate to have him as a partner down here in Florida. So thank you, Ben, as well for being with us here today. So now to the reason why we are all here. So Cognex purchased a Swiss deep learning company named ViDi in April 2017, and then more recently SUALAB in October 2019. So for Ben and I, we've been anxiously awaiting a product that could be commercially released with deep learning capabilities for over 3 years. And while today is not the way that we expected to roll out Cognex's ViDi technology, we are excited that we're able to deliver this message to all of you at once. So since this is such a leap in technology, and I truly believe it to be a very disruptive game changer in our industry, I'll walk through some of the basics of machine vision as we know it to exist today, and then we'll transition quickly to the new technology. So after that, Ben will get to handle the fun part of doing a live demo for you all that I think you'll all be impressed with. He already has his hardware and software at his house, so he's going to set us up with that. So first, as a background here on Cognex, for those of you that don't know them, they're a large publicly traded company based out of Natick, Mass, and they've been working in the machine vision space since 1981. They're now the world's leader in machine vision and barcode technology with over 25,000 customers in 38 countries. They've deployed well over 2 million vision systems and did over $8 million in revenue in 2018. These are the products that you've come to know and love from Cognex. Broadly speaking, Cognex has 2 major areas of focus with machine vision and barcode technology. The 2D vision space is where they sell most of their hardware today, but there's been a large investment in the 3D space lately, and we expect to see more of that in the years to come. So what is machine vision at its core? It's always been the goal to have a camera that can operate like a human from a learning standpoint in order to determine the subtle differences between a good and bad part, but then also do this in a much faster way that is reliable and doesn't introduce the variability that we see from operator to operator. I think we can all agree with that. Machine vision can make decisions in milliseconds and functions very well when it is able to follow the hard and fast rules about what makes a good versus bad part. So this is something pretty common for what we see with today's machine vision capabilities. This is a snapshot from Cognex's Insight Explorer software, and it's very easy for the system to recognize patterns, perform precision measurements when you calibrate the image, read, verify, and output an alphanumeric string, read a barcode, so on and so forth. So this is what we think of when it comes to traditional machine vision as it has existed before today. So let's talk about deep learning. What is deep learning? I didn't know at first either. I had to spend some time on this because It's the first product that I've been working with that goes to this level. So deep learning is a subset within AI and machine vision that uses an example-based approach and an artificial neural network to allow machine learning based on large amounts of data through many layers. As it pertains to Cognex, our system is able to be fed an image library where the programmer simply labels the parts as good or bad, and the algorithms find the subtle differences between those parts without needing to be told exactly where to look like we do today. We have quite a few examples that we're going to be sharing in regards to this as we go through the presentation, and then as I mentioned earlier, you're going to see a live demo as well. So why is this deep learning capability important to you? It goes back to a couple slides ago. You know, we want to have the human performance and flexibility while also having the reliability and consistency of a machine. So what is Cognex's approach to deep learning? Cognex's approach to solving machine vision applications with these tools is now different. We can now utilize examples of good parts and example of bad parts as a supervised way of learning and showing the system good from bad, similar to how humans operate. This is a very different approach from traditional machine vision. I have a 3-year-old daughter, so I can relate to the slide here, but the same way that a toddler learns that every single house in that image above is a house, you know, the machine would learn the same way. So they don't look the same way, but they all can be classified as a house because of a mailbox, a driveway, a roof, windows, and a front door. You know, but there's also exceptions to that rule as you start looking at all these images as well. If you're in a residential neighborhood and all of a sudden you see a sign in the front that says so-and-so's daycare, then hey, that's an exception to the rule. Much like a human would learn, okay, well, that's one exception I need to take into account. The machine vision system can do that as well as you load more and more image examples into it. So it doesn't follow those rigid rule-based algorithms. It's completely example-based. We're starting to see this technology pop up in autonomous vehicles now as well. So in the example that you see here on the screen, the neural network would need to be fed thousands and thousands of images to be able to determine a car from a stoplight, a person in a crosswalk, a biker, so on and so forth, in order for it to be safe. You know, this technology enables thinking like a human, and we're going to see more and more of it in our industry and in our daily lives for many years to come. There's really no wonder why you see those Google streetcars going around, and on Google Earth you can get a satellite view or a street view, and I have to imagine the end goal there is so that could be layered on top of these autonomous vehicles so that you know, the car and the environment looks the same or close to the same for a machine vision system to operate. So we are now launching Cognex's ViDi platform, and we really want to highlight a few of the many tool sets here today that we think will be most popular. The cameras are going to come in 2.3 and 5 megapixel models. We're first releasing the monochrome version, so grayscale, black and white, but the color cameras will follow soon after as well. These cameras are all trained in Cognex's spreadsheet environment as your traditional models are done today. The 3 main tool sets that we're going to hit on are going to be ViDi Check for assembly verification, ViDi Detect for defect detection, and ViDi Read for even your most challenging OCR or optical character recognition applications. When we get into the demo, I think you'll get a better example of that, but we'll walk through some of those. So this is what the new cameras will look like, and you're probably thinking that they don't look any different from the cameras that you're already using, and that's the point. The hardware stays mostly the same in that smart camera format, while the software gets a whole lot better. We still have the IP67 housing, the same cable connections, the wraparound pass-fail indicator LED, the SD microcard HDR+, and as we said, this will come out in 2.3 and 5 megapixel formats for now. So I'm going to quickly explain each tool set with one slide each, and then we'll transition to the live demo. I know that's what you're all anxiously awaiting. So we'll look at some of the examples of once challenging applications that ViDi can now solve. So another item to keep in mind as we're going through these is how much faster the programming of these systems is when you're taking this example-based approach. So first is ViDi Detect for defect detection. So as we said, these are examples that would be challenging to a traditional machine vision system that ViDi can now do pretty easily. So imperfections on medical screws, improper assemblies and solders, scratches on surfaces, which comes up pretty frequently, and weaving problems on textiles. ViDi Read for optical character recognition. All of these applications would be a challenge. In the upper left, we're looking at low contrast characters embossed on an injection molded product. In the upper right, background noise combined with a low contrast mark would make this challenging for sure. And in the bottom, you're looking at an IV bag that would have small characters on a reflective surface where lighting is always going to challenge how you can do that and play tricks on you. Last is ViDi Check for assembly verification. So these have always been kind of a pain in the butt trying to see, for example, the lower left image looking at a medical kit to determine all parts are present in the kit. The electronic component is an example of something that Ben and I will run into really multiple times a year and haven't had a great answer for our customers until now. We can speak to the fact that we know a few customers that have spent 6 figures on custom vision systems to try to do these types of applications, and they're still not happy with the performance. So now we're going to transition over to Ben, let him run the live ViDi demo for you all. Please keep in mind, again, everybody's muted, so if you could type in your questions by sending them in using the chat functionality at the bottom of the screen. We will take some questions at the end of the demo, and then any additional questions will be addressed at the end. So Ben, I'll let you work your magic. Hey, Ben, you're still muted. I can't hear you yet. I cannot hear you.
1 second. Can you hear me now?
I got you.
1 second, guys. Sorry.
No.
All right. Sorry about that, guys. Can you hear me?
Yes.
Okay. Apologies. Technical difficulties from working at home. Thank you, Jeff, for that over generous introduction. I appreciate it. Guys, I'm your friendly neighborhood Cognex guy. And as Jeff said, we've just come out with this Insight D900. So that's what I'm going to be presenting for you today. I got it set up in my office, sort of a live demo. So here's my Insight D900. I got a platform, and I got a handful of tools that I'm going to be kind of using to show you guys sort of a sizzle demonstration, as we like to say. So the very first one we're going to go over is the ViDi defect tool, right? And as Jeff mentioned, basically this is used by training images of good parts and looking for abnormalities or irregularities from those parts. And so it's really useful when finding defects. And what I'm going to be doing the demo on is this carbon fiber sort of woven background. And as you can see, it's almost like a fabric with a high reflectance variability. So you've got like dark areas of shading down here, you know, but then as it waves, maybe that shade moves there and you got some specular reflection here. And anybody that's used traditional, right, machine vision would know that something like that is quite a challenge, right? Changing polarities and things like that. So here are the cards, and this is what I'm going to be training on. And I've got examples of those OK 1, 2, 3, and 4. And on the opposite side, we got some missed stitches, and we're going to be checking that out. So I'm going to walk you through from first principle what programming a system like that would look like. And then after this is done, I'm going to also jump into an OCR demo. So we got all sorts of stuff to cover. And I think they'll be taking questions in the chat, and I think Jenna and Jeff will be organizing those, and there will be a time that we can stop and answer those questions if you like. So how do we do it, right? So this software right here is the Insight ViDi Suite. This is a brand new sort of software introduced by Cognex within the last 2 weeks. It obviously kind of goes along with our product that we just introduced over the last 2 weeks. But for all those spreadsheet users out there, it's using the same exact interface that you're used to, with your tool palette on the right. But now we've made it a little better. We've listened to requests and we've tiled it so that the image that you're seeing underneath the cameras on the left and the spreadsheet programming platform is on the right. On the bottom here, we've got a film strip. And again, remember, all these deep learning tools are all example based. So how do you create all these examples and organize them? Well, you put your images in a film strip and you can rename them and organize them so that you can run them through the system in an organized fashion. So getting things started, right? So just like any other vision system, right? I'm going to hit record on my film strip here so that I can start recording the images I'm taking. So take my first image and just like any other vision system, right? Like you want to fixture your inspection. So what I'm going to do is I'm just going to recognize that Cognex logo so that no matter where in the field of view that pattern ends up, I'm still going to be able to track the part and know where it is. Then I can anchor all my inspections with respect to that. So I changed my pattern region, I trained my event, and now we've got our Cognex logo trained. So no matter where this card is in the field of view, we're going to find it, right? And I'm just doing all that from my my toolbox over here on the right-hand side. But you guys didn't just want to see pattern tools, right? But we do have all of our classic tools, binary linked objects, inspect edges, patterns, all sorts of things like that. But the new stuff are these ViDi tools, right? So you've got your full ViDi tool set, and you got ViDi check, like Jeff was describing, that's for assembly verification. We got our ViDi detect that looks for anomalies or defects. We're about to use that one, so I'm going to go ahead and drop it in my palette. And then we got our ViDi read, which we'll be using after that, which is our OCR detection tool. So just like any other tool, we're going to want to fixture it. So we're going to fixture the region that we're inspecting on this card to that Cognex logo, and then we're going to define that region, right? So simply just kind of cropping down our region of interest so that it includes only the areas that we're interested in seeing on the part. And then that's pretty much it, right? We're good to go. So now I just got to create a sample set of the rest of the images, right? Because I'm going to have to run all those through ViDi. So take another image of card number 2. Take an image of card number 3. An image of card number 4. And finally, just a quick sanity check. We're just going to introduce a failure just because. Just so while we're training, we can make sure that we're finding everything that we need to find. Okay, so now we've got our film strip filled with enough images to actually create a neural network. So one thing that we're going to want to do is rename them, right? These are our good images. So just so we can organize them and go through them later, we're going to append it and say, okay, these are good images, so they're okay, right? And we've got one bad image, so let's just make sure we can identify that later. We'll call that no good, right? So now we're good to go. We can go back into our ViDi detect tool, and we can open up our ViDi editor, which is where you're actually going to train the deep learning tool, right? So still, just like spreadsheet, everything we train in here is going to be dumped out into this cell so that you can organize it and program it in the classic spreadsheet platform. Very, very useful. So at this point, our film strip travels with us over to the ViDi editor. Take our images, drag, drop them into the ViDi editor. We're good to go. All right. We can even minimize our film strip at this point because once they're in the ViDi editor, they're in there and we're good to go. So you can categorize your images in a few ways, right? I've named them so they're really easy to look up. So let's say you had 100 images to create a neural network. I just want to find the ones that are okay. They're predefined, right? I go in here, actions for those views. I'm going to label them as good. Now the system knows that they're good, right? Now ViDi knows they're good, and that's the important part, right? And you can also go through and very simply one-off, click one time for good, twice for bad, and you're good to go. So at that point, everything we've done up till now, we're good to go. We can hit this brain button, and if you have a GPU-enabled laptop, it'll do the training on the laptop that you can then download onto the camera. Now, it may take a couple minutes for that to happen, so what I'm going to do instead is just load this job because I happen to already have it. And that's just a job that I have saved on the camera itself. Okay, here we are. So we're back in our software. Our ViDi detect tool has been trained. Now you can see in the pattern tools, you're getting a lot of data, right? What's the area, the angle, the X and Y coordinate in the image. Very easy to right click on your deep learning tool, your ViDi tool, and select insert getters. You insert getters, so now you can get the area of your defect, the location of your defect, all sorts of stuff, right? So what I'm going to do now is, and one of the other cool features of this software is it has a customizable web HMI that outputs an interface. You can customize it any way you want to a web browser. That's also running off of the camera. Okay, here we go. So now we're running online. So I've customized this. I could put a company logo in here. I've got the job time. I've got the score of the pattern tool going, as you can see there. So here's a good card. We're recognizing it. We can even retrain the pattern region and the fixture right from this interface as well. So let's flip this over and take a look at a misstitch or a defect, an anomaly. Okay, so right now we got our job running about 150 milliseconds. And as you can see, that's our defect. A tiny, small misstitch in the lower right-hand corner. So people that don't know machine vision should be impressed. People that know machine vision should be impressed even more, right, by being able to find something like that. I think we all know, if we've programmed cameras before, finding irregularities like this is, not difficult, but, pretty much impossible. I'll put the rest of the cards through there so we can just kind of go through the whole demo or flow of this thing so we can find all the misstitches. There's another one. And finally, last card. There it is, right? Waving, reflectance, specular areas, shadowing. We're still finding kind of the irregularity in that stitch pattern. Let me show you guys a couple of things that maybe aren't, predetermined by us, right? So here's a card. I'm gonna go ahead and just poke a hole in it, right? So no problem. We can go ahead and find that. I can take that same card and I'll draw something on it, Okay, so I've drew atoms on it because those guys rock. And yeah, we're able to find that no problem, right? So lastly, what if I rip the corner of this card off, right? So I just ripped one of these other cards with the same kind of carbon fiber pattern, and I kind of threw that on top there. Yeah, no problem. We can see that that's still different. A lot of times, again, for people that don't know machine vision, this should be impressive, and you should be seeing some applications in your mind where you think this applies to your facility. Even more so if you know machine vision, this is one of those mic drop moments we like to say, hopefully. So anyways, send some questions in that you have in the chat. For now, I'm going to load the OCR job and move on to that portion of the demonstration.
Okay.
Hey, Jeff, I'm going to try to get these headphones back in and see if they work.
Give it a whirl. We did have a question. How does it handle angles? Say the top of the card was a little higher than the bottom.
Good to go. You guys still hearing me, Jeff?
Yeah, can you hear me?
Yeah.
We had a question come in. How does it handle angles? Say the top of the card was a little higher than the bottom of the card, closer to the lens.
Yeah, good question. No problem, right? But what we're going to want to do in our training set is include those angles. You want to include the variability that you may see in production, right? But as long as you do that, ViDi should have no problem. And Jeff, I'll tell you what, you're looking at the questions. You tell me when to go ahead with the OCR demo, or I'll just answer questions for now.
Yeah, go right ahead, Ben.
Okay. All right. So here's our spreadsheet job for our Insight ViDi Suite spreadsheet job for OCR. All right. So I'm not going to go through the minutia of programming again. You guys all saw that. I'm sure it's cool, but you don't want to have to sit through it again. So I'm just going to go straight online with this and go straight into the demo, into my web HMI that I've customized. Cool. All right, we're good to go. So here's what I'm showing, right? I'm sure you guys all remember transparencies from school, right? Maybe, unless you're too young. But basically, I got a transparency with some OCR font on it. I'm going to put it on this background. I'm going to start reading it. Okay. So there it is. You can see the text in the top left, just so you're nice and zoomed in, and we're reading it. And, you know, wow, Ben, incredible. You're reading text. So, you know, we're doing that right now with all of our awesome traditional Insight cameras. Well, what if I was to take this and I was to rotate it up so the segmentation of those characters completely goes away and actually still be able to catch that, right? You can see my arm on the right is completely lifted up. And I'm just going to bend this till I break it. I'm going to bend this part until I break the algorithm every time. So look at the left-hand side. So totally get rid of that segmentation. What if I take it and I twist it? See the specular reflection going through the 6 there and the 5, right? Before, traditional OCR tools, not just Cognex OCR Max, let's be straightforward. Anybody that's trying to OCR that 6 right now is having a heck of a time with any type of traditional OCR algorithm. Just the way it is. It's the reality of our industry right now, until now, right? Twist it again. We're still finding everything. No problem. Say, how does it deal with changes in polarity and things like that? You know, what if I was to take this this bubble wrap and throw it over there? I mean, are you kidding me? Right? I've spent hours trying to make applications work that were 10 times better than this. Look at that. You know, if you've got to read some text or verify some text, this algorithm is absolutely a game changer. What if we change the polarity behind the text? Right? So we got a nice white background here. What if we slide this black card in the back of it and just kind of move it around? Changing polarity behind it, changing polarity throughout the node so that half of the string has got a dark background, half has got a light, no problem. So I got a second section to this OCR demo that I do. People tend to like it. Basically, I've taped one of these transparencies on a clear water bottle, right? So if you want to try to see like varying backgrounds and things like that, right? What do you guys think of this? So this should be one of those aha moments where, you know, we've spent hours and hours to make sure lensing and lighting is absolutely perfect and our resolution is up to snuff and everything else. And then you should see this and you should be borderline, borderline angry and want to get involved as quick as you can. There we go. Bend it till you break. So we're still able to pick it up on that sort of angle. If I rotate it back, right across the water line, no problem. Let's leave it right across that water line right there. Wow. Bring it back up, shake it around a little bit more. I'll leave that right there. So it's pretty much my portion of the demonstration. Jeff, you can kind of take it from here if you like. Sorry about the issue with the microphone, guys. And maybe I'll stay on for another second if there's some more questions in the chat.
Yeah, Ben, that was great. Thank you. Yeah, we'll give it another couple minutes if anybody has immediate questions in regards to that demo or either of those demos that he just did. If not, we'll continue on with more application examples. Okay, we have a couple questions here. Are there pixel requirements per feature?
Yes, but they're much less stringent, and they also depend on the variability, right? So you can have a little bit more, a little bit less, depending on, right, how much your background's changing and things like that.
There's a question here. Any rough surface example? I think the carbon fiber is probably as rough as we can demo in Ben's house today, but I don't know if you have anything you want to add there, Ben.
Rough surface example for OCR or rough surface defect? Or neither?
Yeah, I'm sure probably either.
Yeah, so I mean, the application examples that Jeff's about to go through, we got some, I don't know if there's some embedded videos or if it's just their PowerPoints, but we've got plenty of examples of us doing all sorts of inspections on textured and rough backgrounds.
Yeah. One more question. How do the ViDi tools affect processing time?
Great question. So on the camera itself, right, because these ViDi tools are actually running on the camera, and what we have is we got 4 ARM processors and they're simulating a GPU. It is going to be fast. You know, we can hit those sub 200 millisecond times, but on the really, really high speed applications, we may have to go to an acquisition only software type solution. But that at that point, it just depends on what GPU is in the industrial PC we spec. The short answer is we can take care of you no matter what your speed is.
Yeah, and I think the main message here and you know is bring these applications to us, and we'll determine the best path forward with this technology. So I think that's all the questions for now, Ben. I'll take the screen back over, and then we'll have time for more questions at the end of the presentation.
Sound good?
All right, so I hope you're all as impressed as I was the first time I saw that. I mean, the ability to read OCR and see those surface defects with all those conditions going on is really unheard of in our industry, and this is disruptive, game-changing technology and as far as machine vision goes. Now, because Cognex has gone through some trials already, we have an application database that we've already built up of successful deployments that Cognex has done already. So let's walk through a few more examples using each tool set in different industries to show the flexibility of sort of that deep learning system. So these are going to be some examples that we go through with ViDi Detect. So this was really impressive to me. In this example, we're looking at an automotive air filter with the complex texture that you have on the part there. Finding the defects on here would be extremely challenging, if not impossible. By feeding the software suite with 100 good images, the system was able to detect defects while also being tolerant of the natural part variation. So if you look at the example on the lower left where it kind of blows up the image for where it found a defect, like being able to say, hey, that's a defect versus the natural part variations that you see is really, really impressive here. Another example is looking at this sort of medical vial. So anytime you're looking at these types of parts, you're going to have reflectivity on the part and then, in this case, they needed to be able to tell the difference between a part with debris on it versus a broken vial that you see there on the left. So that certainly poses a challenge. By showing many examples of good images as well as bad images, it's able to tell the difference between a part with debris, which is good in this case, and a broken vial, which is obviously bad. So if you have parts in dirty environments or deal with transparent materials or packaging, this should speak to you. We talked about the difficulty of dealing with PCB inspection earlier. Due to all the surface mount technology applied or even components that need just general inspection on top of the board, there's a lot of variables that get introduced into that type of a process. So this is a prime example of the camera being able to look at a larger field of view, but being able to find the small deviations that make the part on the left a bad part. So if you look at, again, those blown up images and you see the very, very subtle differences of a misaligned part or a missing component in general, once again, the system can forgive the natural part variations, but pick these up pretty easily. Tortillas. The dark spots on the surface, of course, have to be forgiven. So by loading, again, 100 good images of what a tortilla should look like, you have the example on the right where you have a little bit of a cutout in that left side, but that's a natural, something that you would naturally see in a tortilla, and that's okay. But if you look at the left side and you see the tear, as well as the hole that you'll see in the lower right, of course, those are bad. So another example of being able to tell the differences between the variations in the part and an actual true defect. So really powerful tool set that we have there with Detect. So getting into ViDi Check, this is a nice one, my wife's favorite. In this case, all chocolates are going to naturally look different. If you look at the 4 sets of images for each different kind of chocolate, you can see they all look very different. Would be very, very hard to do with traditional machine vision tools. And it's probably hard to tell, but in the upper left, you see labeled as hazelnut. The upper right is milk chocolate. Lower right is dark chocolate. Lower left is salted caramel. So the manufacturer was able to verify that these boxes were filled with one of each flavor, no more, no less, so they could have these sort of variety packs go out the door. So really cool application here for assembly. This is one we briefly hit on already, but Ben and I get asked about these types of applications with Florida being a pretty heavy medical market. So these come up from time to time. Up until now, we've pretty much had to walk away from most of them. Seeing parts through a reflective bag and being able to verify that all the components inside are inside is very challenging for an automated vision system. In this case, what they did was train all 4 components that needed to be found within each kit, and then the system is able to verify if the kits are complete or incomplete. So, again, this just flat out wouldn't work with a traditional machine vision system. ViDi Read, so getting more into those impressive OCR demos that Ben was doing. So these are probably my favorite because of how complex and challenging they are. It blows my mind. So, we all know what a kind bar looks like. So this introduces, 2 really tricky variables. First of all, you're dealing with transparent packaging causing reflection issues, but that transparent packaging also creates a window to a noisy background with granola and nuts and things of the like that doesn't allow great contrast for the inkjet code here. So ViDi is still able to pick up the OCR string reliably, which is amazing. Really, anybody, the message here, if anybody has OCR difficulties, we should be talking immediately. This is a similar case. We're looking at the bottom side of a transparent container with an inkjet code printed over a very noisy background. And as you can see, ViDi is still able to pick up and decode the string. Another application that Ben and I are constantly called about. So nowadays, many of our beverage plants deal with running a variety of products at the same time, or on the same line, I should say. So they're constantly filling different color products, and they know that, marketing or whoever might come out with a new flavor tomorrow. So being able to have something flexible that can adapt to these changing conditions with changing opacity, ViDi is still able to read the string despite those varying levels of opacity, as well as issues like bubbles or, we've even had cases where the code is being intersected by the fill level line, and that's something that ViDi would be able to knock out of the park. So, a common theme here, and we're seeing that, is this is an iPhone case with another noisy background. The message here is, bring us your most challenging OCR applications and let's have a look at it with ViDi. All of these applications are great examples of things that we would really, really struggle with in the past. So after all of our pumping up of the deep learning capability, will this mean the end of traditional machine vision? And, the answer is just flat out, absolutely not. Cognex still has the best algorithms in this space. They're still the world leader in machine vision when it comes to traditional machine vision products. So we still want to lead with those if they're going to work. What we're really getting at here in the applications that we need to be looking at with ViDi are the applications where the existing camera technology is struggling to perform to meet your needs, or for applications where they were just not possible with today's technology. So those were rules in the past, or there were rules in the past when I started with machine vision, and I was told, hey, if God made it, don't touch it with machine vision. And basically saying, like, if you were going to go take a look at, and we'll get calls for this, cuts of meat or fish, no two cuts will look the same, and the traditional tools would never be reliable. But now with ViDi, again, going back to make the impossible possible, we encourage you to go back and look at applications that either failed or you never thought the technology could handle them. So what is different and how do we use this technology? So to use ViDi, Ben hit on this, but you would use a GPU-enabled laptop so that you have the processing power for the number of images that you'll want to load into the library. For optimal performance, it's recommended by Cognex at the factory that you work with an image database of 100 images and just label them good and bad. We realize that sometimes not that many are possible, and of course there's cases where you can get by with less. So, Ben and I, for example, did one of these evaluations on site with a customer a few weeks ago. I would guess, Ben, we had about 20 good and 20 bad images, just taking the same two parts and taking different angles of them. And once the images were loaded and trained in the spreadsheet, that project ran on the embedded system within the smart camera as a standalone device, and it was perfectly fine. So, and that's the other part here. So you work with a GPU-enabled laptop, you train all the images and configure the application in the spreadsheet, but then the embedded system that's in the D900 series camera will allow it to operate as a standalone device inline. So when I ran through the presentation, I'm sure a lot of you were thinking, I can't wait to see the price on this thing. But these ViDi systems are really fairly priced within the machine vision system market. The cameras themselves will range from $11,500 to $18,500 depending on the resolution and the tool sets needed. So to really put that in perspective, our 12 megapixel traditional cameras run around 15K. So you're still in that same range. You're just getting a lot more capability within that price range. So Cognex wanted to decrease barriers of entry and really allow our customers to get their hands on this technology quickly and also remotely while everybody's working from home. So they're offering a really attractive package for getting customers hands-on with this technology. And the goal really here is to stay within an MRO type budget so it doesn't have to go through layers of approval and multiple signatures. So there are two packages that we want to highlight as introductory lab kits. The first package includes the 13-month training dongle that includes traditional machine vision tools and the three that we highlighted today. So ViDi Detect, ViDi Read, and ViDi Check. This also comes with 2 training seats for 2 days each with online live remote training available. That package is going for $3,500. Most of you that have gone through a Cognex training class, either here or at Cognex, know that you've paid at least $1,500 for a 2 to 3 day class. So the fact that we're able to give away a 2-day remote live training course as well as the ViDi dongle is a hell of a deal right now. The other package that we have here and we included in this is everything that's included in the first package, but also includes the other deep learning algorithms that we weren't able to highlight for you today, but that are included in that ViDi suite outside of just ViDi Check, ViDi Read, and ViDi Detect. So that complete package would go for $49.95. Again, we're trying to keep this within an MRO budget so that it's something that our customers can get hands-on with immediately. If you do have a need or think that this technology applies to your applications, I would strongly recommend purchasing one of these licenses with a training package. Again, Cognex wanted to eliminate barriers of entry within this technology, and this is as attractive as it's going to get. The other way that you can work with Adams and Cognex is we would encourage you to bring us parts and applications and allow us to do evals so that we can prove out these applications. That's whether it goes with traditional machine vision or with these deep learning algorithms. We're here, we have a vision lab in Tampa. We're more than happy to go through and do an evaluation for you to prove out an application. Ben's got a nice vision lab set up at his home in Sarasota as well now. So we're ready, willing, and able to help you guys with any application you want to throw at us. So any questions in regards to that? And Jenna, I can't see the questions, so if there are any there, just let me know.
None.
Okay. So thank you all for your time today. You know, we really appreciate all of your time, especially taking an hour out of your day, allowing us to show this new disruptive technology. You know, at this time, we really want to open it up to any questions that you may have had about the demo, about the license, the technology in general. We'll hang out here for a little bit longer and allow that to happen. Otherwise, our contact information is here on the screen now. So if you feel more comfortable reaching out to us offline, by all means do so. And at this point, you can either unmute and ask any questions you may have or type them into the chat.
Nice. Thanks, Jeff. Nice job. Man.
Thank you, sir.
Question for you, Jeff. Will video presentation be available?
As long of this presentation, is that the question?
Yes.
As long as Jenna hit the record button at the beginning and end, we're good.
I did. So there will be recording.
Yeah, so we'll be able to share that with you, so you can share that within your organizations as well. Jenna, do you know how that goes out? I know it goes to Microsoft's stream, but then how do we get it out to our customers? Can we just email it or put it on YouTube or something?
Yeah, I get a copy of it after we wrap up here, so I will make sure and get the MP4 file to everyone who wants it. Okay, great. And it might be, it should be too large to email, so we'll make sure it goes on to SharePoint or something like that that everybody can access and download. Yes. What is the max speed of parts?
I'll take this one, Jeff.
Yeah.
So, you know, we've accomplished applications that involve ViDi, you know, below 20 milliseconds, depending on the inspection criteria. So it is totally dependent on the application itself and the tools required to get it done. But again, it's just completely application dependent. We've had applications that are below 20 milliseconds, and we've had other applications where we're looking at a pallet of 100 parts at one time, and it takes 2 seconds to process.
Any other questions that we see there, Jenna?
Yes. Yeah, is the interface available to communicate with in LabVIEW?
Hey, great question, Anthony. Yes, absolutely. We also have a great relationship with a lot of integrators that have the entire library built for our spreadsheet platform that interfaces directly with LabVIEW. But yes, we communicate with LabVIEW in all sorts of different applications, and it's a common request. Good questions, man. Good group.
Yeah. All right. If there are no other questions at this time, we'll wrap this up. Again, you know, our contact information is on the screen.
Jeff, we got another one real quick.
Okay, go ahead.
Yeah, Oscar, good question. Communication protocols. So there is there's an I/O card. There's an Ethernet card inside of each unit. So we come equipped to talk with Ethernet IP, Profinet, Modbus, with Mitsubishi. Just about every single factory protocol is available within the camera. If you needed a specific list, we can give that to you. More than likely, I've named one that you're interested in. If I haven't, get with me. I'll get with Jeff or the Adams team offline. EtherCAT. Yeah, we have ways to communicate with EtherCAT through some communication bus protocols and things like that. I can answer that question offline, Jose.
All right, no other questions there, Jenna?
No other questions.
All right. Well, we'll close it out. Again, please reach out to us. Let us know how we can help you. And we look forward to working with you on this technology.
Thanks, guys.
Thank you.